Hello viewers, today we are going to see a problem based on reduction formula or using reduction formula. So the question is, prove that the reduction formula for In is equal to integral cos nx dx is In is equal to 1 by n cos n minus 1x into sin x plus n minus 1 divided by n into in minus 2. So this is the question. So we have to find the reduction formula for this. That is, it is given as in is equal to cos nx dx. This cos nx dx can be written as in is equal to integral cos nx dx. So this cos nx dx is equal to cos n minus 1x into cos x. That is, here cos x means power 1. Bases are equal. Therefore, powers can be added. So n minus 1 plus 1. This minus 1 and plus 1 gets cancelled and you will be getting cos nx. For example, cos 6x can be written as cos 5x into cos x. Now what is 5? This is 6x. Cos x power 6. So 6 means here you will get 5. That is, if this is n, this will be n minus 1. That's how I have written here. Okay. So the next step will be, this is of the form u dv. So we all know that u dv, the answer is uv minus integral v du. This is integration by parts. Okay. The next step. So now what is u? U is cos n minus 1 x and dv is equal to cos x dx. Now integrating both sides, this will become b. Integration of cos x is sin x. Now here du by dx. So this is nothing but cos x whole power n minus 1. This is of the form d by dx of z power n, which is nothing but n z power n minus 1 into dz by dx. So this is the formula we are going to making use of. So now what is z? Z is nothing but cos x. The power is n minus 1. So the answer for this is n minus 1 into cos x, n minus 1 minus 1, that is n minus 1. Here we have n as n minus 1 minus 1. So this will become n minus 2. Then differentiation of z, that is cos x, if you differentiate, you will get sin x minus sin x minus sin x. So once again I repeat, du by dx is n minus 1 into cos n minus 1 minus 1, that is n minus 2x into differentiation of cos x is minus sin x. So now what will be the du? Du is equal to n minus 1 into cos n minus 2x into minus sin x. This dx has gone that side. Okay, this is du. Now we have to substitute here, that is uv minus integral v du. That is in. So in will become in is equal to uv. What is u? U is this one, cos n minus 1 x u into v. V is here, uv minus integral v du. V is here, what? Sin x. And du is here, du is n minus 1 into cos n minus 2x into minus sin x into dx. Okay. So the next step will be, this term will come as it is, no change, minus, you bring this minus sign outside, so this will become plus. You bring this n minus 1 outside the integral, so this will become n minus 1 integral sin x into sin x is sin square x into cos n minus 2x into dx. So this will be the next step. The next step will be in is equal to, this step will come as it is. Okay, this term cos n minus 1x into sin x will come as it is, plus n minus 1 integral sin square x. Sin square x is nothing but 1 minus cos square x. So this sin square x is written as 1 minus cos square x into cos n minus 2x into dx. Okay, right. So the next step will be, this term will come as it is, plus n minus 1, so integral cos n minus 2x into 1, that is cos n minus 2 x into dx. This is one part of the integration. The next part will be, so next minus dx minus integral this term multiplied with this term. So here you have the power as 2, here we have n minus 2, base is same, cos x. So base is same, powers can be added. So this 2 and minus 2 will get cancelled. So you will be having cos power nx into dx. Okay. The next step will be, see, in the beginning we have written in as in equal to integral cos power nx into dx. Therefore, n minus 2 will become cos n minus 2x into dx. So from this we can write this as in minus 2 minus this integral cos nx as in. Okay. Since we have declared in is equal to integral cos nx dx, therefore in minus 2, in the place of n we are replacing by n minus 2 x into dx, that's all. So this we have to remember. So the next step will be in is equal to, this term will come as it is, plus n minus 1 Inside the bracket we have in minus 2 minus in. Okay. So now in equal to, bring this will, the term, first term will be as it is, no change, plus you multiply here n minus 1 into in minus 2 minus n minus 1 into in. So the next step what I am going to do is I am moving this term, minus term, to the other side. So what will happen now? In equal to in plus n minus 1 into in is equal to this term. First term will be as it is. Second term will be plus n minus 1 into n minus 2. Now this in plus nin minus in is equal to, this term will be as it is, plus n minus 1 into n minus 2. Now if you see in gets cancelled. Now nin is what? Nin is equal to the first term will be as it is, which is nothing but, first term is cos n minus 1x into sin x into sin x. So this is the first term. The second term will be plus n minus 1 into n minus 2. Now divide this equation by n, divided by n, divided by n, and divided by n. Now this results in in is equal to 1 by n cos n minus 1 x into sin x plus n minus 1 by n into n minus 2. Hence proved. Hence proved. So this is the answer we should get, and we got that answer. So this is the way we have to solve this problem, by the method of reduction formula method. So the answer is in is equal to 1 by n cos n minus 1x into sin x plus n minus 1 divided by n into in minus 2. Hence proved. Hope you have understood the reduction formula of in is equal to integral cos power n x into dx is this value, in equal to 1 by n cos n minus 1 x into sin x plus n minus